The James Webb Space Telescope has discovered something truly extraordinary. Beams of light that appear to radiate from a city center shining from a location light years away. This discovery has revived interest in the possibility of extraterrestrial life. The focus of the telescope was set toward Proxima Centauri b, the closest known exoplanet to our solar system. It observed odd, brilliant flashes of light, which could be an indication of an alien civilization. Keep an eye out for more. Over the years, advancements made by both scientists and everyday people have fueled fascination with the concept of life beyond Earth. Any indication of the presence of life in outer space has always been met with excitement. A pivotal moment occurred when the James Webb Space Telescope presented what could be clear proof indicating the existence of life. While scanning the depths of space, this powerful telescope discovered something extraordinary on an exoplanet. Because it was so far away, the lights it detected resembled those from extraterrestrial cities, igniting the possibility that an alien metropolis might exist on a distant planet. This concept has produced significant excitement and curiosity within the scientific community, as it could be the breakthrough they have long anticipated. It hints at the presence of intelligent, operating civilizations in a way we are only beginning to understand. The investigation into these lights, resembling those of a large city 4 light-years away, is ongoing. At this moment, NASA engineers are astonished and wonder just how long these lights might have been visible in space, awaiting the development of technology advanced enough to detect them. David Kipping, an astronomer at Columbia University, has described the planet where these lights originated as especially unique. Unlike most rocky planets, it appears to absorb the sun's energy and release it as ultraviolet light. This exoplanet behaves differently due to its unusual relationship with its host star, Proxima Centauri. This is what the James Webb Space Telescope has discovered. The telescope's ability to capture infrared wavelengths was essential in identifying the unusual behavior of Proxima Centauri b, which is critical for understanding the planet's atmospheric conditions. Researchers plan to continue using the telescope to study this planet's atmosphere in greater detail, with hopes of investigating its habitability. The James Webb Space Telescope is particularly sensitive to infrared light, allowing it to observe phenomena even during events on Proxima Centauri b. Many telescopes struggle to discern faint light in the vast void of space, especially at night, but the Webb telescope excels at recognizing even the tiniest glimmers. This makes it an excellent tool for confirming whether the alleged city lights on the dark side of Proxima b are real. The telescope can detect artificial light in space, provided it falls within a specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b interacts closely with its star, which heavily influences its surroundings. Like many planets orbiting stars, it captures intense energy from Proxima Centauri. As the planet revolves around the star, it experiences day and night cycles similar to those on Earth. The temperature range on Proxima Centauri b is vast, primarily due to its composition. For example, if the planet lacks an atmosphere, the temperature difference between day and night would be extremely high, scorching heat on one side and frigid cold on the other. This dramatic thermal fluctuation is a key area of interest for astronomers, as it provides valuable clues about Proxima Centauri b's atmosphere. The James Webb Space Telescope, with its ability to image in the infrared spectrum, can effectively examine global heat emissions, offering insights into the planet's atmospheric properties. Interestingly, the telescope's orbit around Earth aligns with the orbital period of Proxima Centauri b, allowing scientists to make detailed observations of its day-night cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step will be to analyze its chemical composition to determine if it could support life. Detecting elements like oxygen, water vapor, and methane would suggest the planet's potential to harbor life. This would involve studying the light passing through the planet's atmosphere, a difficult but vital process. While the James Webb Space Telescope is fantastic for characterizing planetary atmospheres, it was primarily designed for other types of observations. Its strength lies in detecting concentrations of water vapor, carbon dioxide, and methane. However, it is less adept at detecting free oxygen, an important indicator of life. Nonetheless, the telescope can search for other key indicators like ozone, which suggests a healthy environment. As scientists examine the data gathered by the James Webb Space Telescope, the hunt for distant worlds continues. The search is bringing us ever closer to answering the question: are we alone in the universe? It's important to note that the James Webb Space Telescope can only observe a limited number of exoplanets close to Earth. For more detailed studies of planetary atmospheres, astronomers will rely on ground-based observatories like the ELT, Extremely Large Telescope, which is set to begin operations in the near future. The ELT is intended to provide a more in-depth look at the atmospheric structures of far-off exoplanets, offering clearer and more detailed information about their capacity to support life. Scientists are eagerly awaiting the launch of upcoming spacecraft. Until then, telescopes like the ELT and the James Webb Space Telescope remain invaluable tools in our search for life beyond Earth. Despite its limitations, the Webb Telescope continues to offer critical information that may change our understanding of what lies beyond. Solar system scientists have high goals. Plans for future space telescopes aim to develop technologies that reduce interference from starlight, allowing for better observation of the planets around them. This is similar to blocking the sun with your hand in order to see more clearly. These upcoming telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and determine whether they might be able to support life. However, this is not an easy task. Stars are extremely bright, frequently outshining their surrounding planets. This brightness makes it difficult to detect the faint light that planets reflect, which is essential for studying their characteristics. To address this challenge, scientists are working on several innovative techniques. One such method calls for the utilization of coronagraphs. These devices are installed within telescopes to block out starlight while letting the light from the planet pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the brightness from the star, facilitating the detection of the dim light from exoplanets. Another promising approach is the starshade, a massive, flower-shaped spacecraft that will fly in formation with a telescope. Positioned tens of thousands of kilometers away from the telescope, the starshade blocks starlight before it even gets into the telescope, only allowing the light from exoplanets to reach the instruments. This technique could be particularly effective in observing planets in the habitable zone of their stars, where liquid water and possibly life could exist. However, these advanced technologies require exceptional precision. For example, the alignment of a starshade must be perfect to millimeter-level precision over vast distances. Moreover, these innovations must overcome the limitations posed by space missions, including the need for miniaturization, energy efficiency, and the ability to withstand the harsh conditions of space. Despite these challenges, the potential rewards are enormous. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators such as oxygen, methane, or water vapor in specific ratios. These molecules might point to biological processes, suggesting that life exists beyond Earth. Researchers are also looking into direct imaging techniques for future distant worlds in greater detail. Telescopes could be equipped with advanced adaptive optics that compensate for distortions caused by Earth's atmosphere or the motions of the telescope, resulting in sharper images. Combined with technologies that block starlight, these enhancements may make it possible for scientists not only to detect exoplanets but also to map their surfaces and study their climates. The development of next-generation space telescopes represents a significant advancement in our efforts to answer one of humanity's most profound questions. Are we alone in the universe? By enhancing our ability to observe these distant planets, we are getting closer to determining whether life exists beyond Earth, potentially transforming our understanding of our place in the cosmos. The future of space exploration and the search for life beyond Earth is advancing at an unprecedented pace. As scientists and astronomers dive deeper into the enigmatic worlds of faraway exoplanets, the James Webb Space Telescope is opening a new era of cosmic discovery. The data it gathers assists astronomers in groundbreaking revelations about the structure and potential habitability of far-off worlds. With each new discovery, we are getting closer to answering the ultimate question. Is there life beyond our planet? Proxima Centauri b, the closest exoplanet to our solar system, could become a major turning point in how we approach research on life from another planet. Proxima Centauri b has been the subject of extensive research for years, but to this day, finding concrete evidence of life, such as signs of artificial light or civilization, was a dream for many scientists. The fact that such light has been found by the Webb telescope bolsters the hope that we will one day communicate with other intelligent life in the universe. This kind of discovery fuels both scientific curiosity and public imagination, inspiring new generations to think beyond the confines of Earth. As the James Webb Space Telescope continues its observations, it's not just looking for synthetic lights but also focusing on planets' atmospheres, their chemical compositions, and how these factors could support life. The search for biosignatures like methane or carbon dioxide in the right concentrations is vital for understanding whether these planets have the right conditions for life. The Webb telescope has the ability to look at these atmospheric components in a way no other telescope has been able to, bringing to light the potential of distant worlds where life could flourish, similar to Earth. One of Proxima Centauri b's strengths is its location within the habitable zone of its star, where conditions might be right for liquid water to exist on its surface. The habitable zone is the region around a star where temperatures are just right, not too hot and not too cold, for liquid water to form. This is considered an important factor in deciding whether a planet could harbor life. Water is essential for life as we know it, making the discovery of an exoplanet within a star's habitable zone an important target for future missions. In addition to finding life-supporting planets, future space telescopes will also focus on the complex relationship between exoplanets and their stars. Some planets, like Proxima Centauri b, are tidally locked, meaning one side always faces the star while the other side remains in darkness. This can create extreme temperature differences between the two sides of the planet, which would affect the planet's climate and its potential to support life. Understanding these conditions is critical for astronomers as they assess the likelihood of habitable environments on exoplanets. The development of technologies that can block out starlight is an important source of bright light in space exploration. Without the ability to block out starlight, it would be virtually impossible to observe the faint glimmers of light from distant planets. The coronagraph and starshade technologies cited earlier are excellent examples of how scientists are getting around these challenges. By blocking out the overwhelming brightness of a star, these tools will enable telescopes to detect the faint light reflected by planets, which could reveal crucial details about their surfaces, climates, and potential for life. Another exciting development in this field is the concept of directly exploring exoplanets with the aid of starlight and advanced adaptive optics blocking technologies. Astronomers hope to take high-resolution pictures of planets as they revolve around their stars. These images would not only provide more comprehensive data on the planet's composition and atmosphere, but could also offer a closer look at surface features such as oceans, continents, or weather patterns. This kind of imaging would represent a giant leap in our ability to study exoplanets and make informed decisions regarding their potential to support life. As we continue to explore the universe and search for answers about the existence of life beyond Earth, the role of the James Webb Space Telescope and future missions will be indispensable. The telescope's ability to detect distant faint signals, analyze exoplanet atmospheres, and examine their potential for habitability is transforming our understanding of the cosmos. With technological advancements and an ever-growing body of research, we are on the brink of making discoveries that could alter our understanding of life in the cosmos.